Hello, good evening, everyone. Welcome to this session of BARTI. Thank you, BARTI, for giving this opportunity, and thank you, Rajiv sir, Rajiv Gandhi sir, for organizing this particular session. So, friends, as we are discussing electronics and experimental methods for last 5 6 lectures, and today we are concluding this by just by doing revision what we have done in last 5 6 lectures, and some topics are still left, like analog to digital converter or digital to analog converter, that also I am trying to share in today's session. So friends, as we know, the electronics, how it is important for the syllabus of NET and SET, as a physicist, how electronics plays a very vital role. Because if we see any of the circuitry, so any of the circuitry, then it must have some electronic component. Without that, we cannot imagine the electronics. Even though if we are talking about the recent mission like Chandrayaan 3 or the Aditya L1, so we can't imagine this kind of the mission without electronics, and whatever electronics we learn during these all sessions, so this every kind of the component is part of any of the devices, and that is why we cannot ignore electronics, and we cannot segregate electronics from the physics. So always we can say the electronics is the integral part of the physics. So, friends, during this journey of learning this particular chapter, electronics and experimental methods, we have covered this much syllabus, wherein we have begin our syllabus from the semiconductor devices. And as we know, whenever we are talking about semiconductor devices, then just simply you can imagine the journey, or like what we can say, the revolution in semiconductor physics begin around 1950s. So in that way you can see it's a only 70-year-old physics, and again beyond that we can see how much development is there in terms of the semiconductor devices. And if we don't have the semiconductor devices, then we could not have imagined about the mobile phone which we have today. So even though we may be knowing about the supercomputer or any of the computer in earlier days, which used to take the space, as we may be knowing, or we may heard sometime, as it that particular computer used to take the space about entire room or entire any of the Bangalore. So this kind of the space, this kind of the devices now replace with the help of very small a small mobile phone, as you can imagine, and mobile phone can do all the computing work, and you can imagine these all things happen only because of the revolution in semiconductor technologies. And in semiconductor, if we talk about the devices, then the simple and the most important device is a diode. Because as we know, if we are taking the p-type material or the n-type material, then it doesn't have any work. And if we combine p and n and we can make a p-n junction, then we know we can have lots of applications. Even though if we talk about the p-n junction diode, then the simple semiconductor diode can be used as a rectifier, where we can convert AC to DC. Because that is also the most important, because if we see the electronics, so wherever there is electronics, there is a power supply. And if we talk about power supply, then the most important component of the power supply is like a what is the most important component of the power supply? That is the rectifier. So after like a transformer, there must be rectifier. With the help of that, we can convert AC to DC. So again, in that way, there are different types of diodes. Like we are having the Zener diode, and as we know, with the help of Zener diode, we can perform different functions. So if we use the Zener diode, then we know, so we can have the functions like, means simply the voltage regulation can be achieved with the help of Zener diode. So it is again the PN junction device. So in addition to this, like a simple PN junction diode or the Zener diode, there are another devices as LED, as we know, the variac diode, tunnel diode, photodiode. So and everywhere there is a junction, and because of this junction, as we know, how many functions we can achieve. Somewhere we can use it as a detector, somewhere we can use the diodes for sending the signal, or for receiver, detector, or the sender. In that way we can have lots of functions which can be carried out with the help of simple PN junction devices. So in addition to a simple PN junction diode, as we know, there is another kind of the devices we call the transistors, where instead of two junction, means like a two legs, or two like a two terminals, we are having three terminals, and that is why we can say it can be known as a transistors. And as we know, there are different types of the transistors, where PNP and NPN transistor, and how they are useful, how their characteristics are there, and how their characteristics can be utilized for getting the different operations. And even though, as we know, if we are talking about the transistors, then we know the most important function of the transistor to amplify the signal. And according to the need of amplification, we are having CE, CB, and CC amplifier. And again, in every amplifier the gain is different, and according to the values of the gain, we can have different functions of the different configurations in case of the transistors. So this is what, like, the case for the bipolar junction transistor. But again, in addition to that, or apart from this bipolar junction transistor, there is a unipolar junction transistor also. And again, in case of unipolar junction transistor, as we know, we are having the FET or the MOSFET, or we call it the IG FET. And again, it has some different functions in comparison to the bipolar junction transistor. And even though it has certain advantages and disadvantages over the bipolar junction transistors. So in that way, but again, if we see in detail, these all are also the semiconductor devices. Without semiconductor, we cannot form this kind of the junctions. So this is what we have learned related to semiconductor devices. Then we have seen the device structure, how the structure of PN junction diode is there, how the current can be passed, how much potential difference we have to apply. We call it the biasing. So the biasing, the way of biasing, as we know, the forward bias as well as the reverse biasing. So that also we have seen in terms of the semiconductor diodes, as well as in case of the transistor, we have seen how to make the biasing. So simply when we talk about the like a common emitter or the common base or common collector, then we know the emitter to base junction is forward bias and the base to collector junction is reverse bias. This is for the normal operation, but we can make both the forward, both the reverse, and the like opposite to emitter to base is reverse and base to collector is forward. But this is what we can use for the extraordinary applications. But for conventional application, we must use emitter to base junction as a forward bias and base to collector junction as a reverse bias. So friends, in that way we can use transistor for the different applications. And again, as we know, transistor can be used as an oscillator. So simply we may be knowing we can convert AC to DC, but sometimes we have to convert DC to AC also. And if we want to convert DC to AC, then we know we can use the oscillator circuit. And if we are talking about oscillator, then there must be frequency. Oscillators are frequency dependence, and depending upon the output frequency of the oscillator, we can have different applications of the oscillators also. And again, accordingly, we are having different oscillators, types of the oscillators, like Colpitts oscillators, RC coupled, and all like the transformer coupled, RC coupled. So these all are the, and accordingly we must be knowing that there is a class A, class B, class C, class AB kind of the means oscillators and amplifiers are there. So friends, in that way, we know how semiconductor devices are most powerful and can be used for the several applications. So in addition to these semiconductor devices, then again, we can proceed to certain category of the materials we call the optoelectronic devices. But again, if we see in detail the optoelectronic devices, the most of the devices are made up of the semiconducting materials. But if we are talking in broader sense about optoelectronic devices, then only semiconducting material cannot suffice the purpose of it. So in addition to semiconducting material, there are certain other ceramic materials or the other category of the materials that can also exhibit the properties of optoelectronic devices. And because of that, as you may be knowing, if we are talking about solar cells, then in case of the solar cells, the conventional solar cells are the silicon based. But again, in addition or apart from these silicon based solar cells, we know we are having different kinds of the solar cells, wherein we can have the solar cells, like a category of the solar cells are we can say the dye sensitized solar cells, we call it the DSC, or again the perovskite solar cells. So in that way, there are different types of the solar cells are there. Then again, the photo detectors, as we know, the photo detectors, with the help of that, we can detect the signals. And photo detectors are mostly like a PN junction base. And again, so these photo detectors are PN junction base, and with the help of that also, we can execute some functions. So again, these photo detectors, you can see And after that, the leds are, as we know, if we are talking about leds, so leds are light emitting diodes, and as we know, the leds can perform the different functions. And in case okay, in that we know the different functions, like so if we are talking about led, so the different functions, as we know, it can be used as a used for sending the signal through optical fibers, or even though means other than optical fibers also we can send the signals with the help of led. And again, other than that, as we know, if we are talking about led, it has several applications. Even though nowadays leds can be used in a plant growth, and for the for the growth of plant, some blue leds or the red leds or the green leds sometimes are used, uh, used with their appropriate wavelengths. So in that way, leds are used for several applications. Then, along with that, as we know, the LEDs can be used for the for like a, suppose the means if we can make the UV LEDs, and then UV LEDs can have some different application in medical science. So in that way, we are having different LEDs, and then that can be used for several purposes in electronics also. So in that way, you must know what are the applications of the electronic devices and for what purpose they are made. So along with basic, you must know certain applications, and that is really essential to understand the electronics and the depth of the electronics also. So in now also, in addition to these optoelectronic devices, other part is given in the syllabus of net and set, and that is the operational amplifiers and their applications. So as we know, so we are having the transistor based amplifiers, but that cannot serve the entire purpose of the electronics, and that is why new kind of the amplifiers or the class of amplifier comes into the picture, and that is what we call it as a operational amplifier. And operational amplifier is a really versatile devices, and with the help of that we can perform different logical operations, and one amplifier can use for the many applications. And in that way, the operational amplifiers also we have been discussed in previous classes, and also we have discussed their applications as adder, subtractor, or the multiplier and all like that. So this is what also we have seen, we have discussed in previous classes. Then like a digital techniques and applications, so we have discussed about the registers, then the counters, comparators, and the similar circuits, how these are also playing a vital role in terms of the electronics. And in addition to that, you may be knowing the logic gates also logic gates are most important component in terms of the electronics. So friends, and the next part is here, like analog to digital and digital to analog converters. Now we know, means in most of the devices nowadays, if we are having analog signal, then analog signal cannot suffice the purpose of the devices, and that is why we have to convert analog to digital. And sometimes if we convert digital analog to digital, then at the end we may require the analog signal, and that is why we have to convert digital to analog also. And to convert this, we are having different circuitaries that also we will try to discuss in coming slides. So, and again, there are certain various applications of this also. Then, after that, we have seen like a microprocessor and a microcontroller basics. So, as we know, we are having the IC 8085 or 8086. So these are the basic ICs for the microprocessors. And microprocessors, as we know, with the help of these ICs, we can do many computing operations. And we can say that the microprocessor or the microcontrollers are nothing but the basic of for any of the computers which we have today. So that is why learning microprocessor is most important. And you may be knowing, you might be using, everybody might be using the book written by the book. There are different books so that you can use there. Then the data interpretation and analysis. So friends, whenever we are just calculating, or whenever we are taking some data, then the interpretation of the data is most important. If we are not doing interpretation of data appropriately, then really that data is not of use. So data interpretation and data analysis is most important, and for that purpose, we can represent data in the form of graphs, as you may be knowing. So in the form of graphs, we can show the data, and again, if we shows the data in terms of the graphs, then we know we can have wonders, and we can represent, we can even though analyze the data very appropriately. So and again, as we know, whenever we are having the data interpretation, then we must go for the precision and accuracy. So precision and accuracy also plays a very vital role. So we have devoted one lecture on that. So you can go back to some recorded lectures, and you can see how precision works and how accuracy works, and what is the difference between the precision and accuracy, and how it plays vital role for the analysis of any of the signal. So that also we have done in previous lectures. So along with this, we have done the error analysis, and we have seen the propagation of errors and least square fitting. So as we know, whenever we are plotting any of the graph, then for the best fitting, we can have the technique we call the least square fitting. And with the help of least square fitting, we can fit the graph. So that also now we know, and we are using this, and you may be knowing, you may be using one of the book like numerical methods by SS Sastry. So in that book, it's given very fantastically. So friends, in that way, this syllabus we have finished during this particular during this okay, so during this time we have finished this all. Now let us proceed to again in detail what we have done, and then we can conclude with this. So whenever we are talking about electronics, then which is most important relation according to you? Can anybody tell me? So I am waiting. I am just looking into the YouTube. So please tell me which is most important relation according to you. Then we can move ahead. Okay, so yes, we got some responses. So friends, as we know, whenever we are moving towards the electronics, then we know the Ohm's law plays a very vital role, because any or every electronic circuits runs on the basis of potential, or just by applying the potential or the certain potential. Without potential difference, or the without voltage, applying voltage, no device can run. And that is why Ohm's law plays a very vital role in any of the electronic circuitry. And that is why in the initially, or the in the beginning, we have discussed about the Ohm's law. And as we know, the means and in case of the Ohm's law, as we know, as the voltage plays a very vital role. Along with that, once we apply the potential difference or the voltage, then there is a generation of the current into the circuit. But again, so there is certain resistance, or the resistors are there, and again, as we know, the values of resistor gives us the Means as we know how much resistor should use in any of the circuit, and again if we use in series then what will happen, if we use in parallel then what will happen, that we know, that we have learned already. Even though along with that some capacitors are used in any of the electronic circuit, then if we are using the capacitor in series, then how their resultant will be. If we are using capacitors in parallel, then how their resultant would be. So in that way, these all components plays a very vital role in any of the electronic circuitry, that also we have seen in detail in earlier classes. So let us see here, we have given one of the example of the batteries, and as we know the battery can be used as a source. So as everybody knows like that. Now the one of the most important part which we learn during this particular chapter is the, as you may be knowing, the power supplies and the regulation. So why it is required? Because in most of the electronic circuitry, we require the direct current. We call it a DC. We don't want the AC. And to get the DC, we want the power supply. If we talk about power supply, then already I have told you, I have mentioned you while discussing about the diode. Diode plays a very vital role in power supplies. How it plays? So as you may be knowing, diode can be used as a rectifier. And simply if we use single diode, then we know we may have the half wave rectifier. If we use the two diode, then we can have the full wave rectifier. And if we use the four diodes, then we can convert the rectifiers into the bridge rectifiers. And as you may be knowing, the bridge rectifiers are the best type of the rectifiers because the efficiency of the bridge rectifier is more and the ripple factor is less. And that is why diode can be used in any of the electronic circuitry or electronic devices for the conversion of AC to DC. So as simply we have discussed how this PN junction is there and how it can be used. So again, we have seen about the LEDs also, though if we talk about LEDs, so simply we must know some of the things because it is also important to give the answer for the objective type of the question. So the in every LED, you can see the main difference is material is more exotic than silicon used in ordinary diodes or the transistors, and typically 2 volts drop instead of 0.6 volt drop that we know that we can get in case of the LEDs. And when electron flows through the LED, less energy by emitting a photon of light rather than vibrating lattice. So that doesn't generate the heat, that emits the light more, and that is the peculiarity of the LED. And because of that, efficiency of LED is 30%. And if we talk about any of the incandescent bulb, so the tungsten filament or any of the, then it has only efficiency up to 10%. So in that way, you can see how the LEDs are more efficient as compared to the incandescent bulb. And simply you can see must supply the current limiting resistor in series. So simply you can see how it is. So now you can see getting DC back out of the AC. Simply this is the AC. We are using the half wave rectifier. Here the load resistor across which we can get the DC, and this is what you can see. The simply you can see the just let me take the laser pointer. So here you can see this is the sine wave, and if we are using the diode, then you can see the half wave rectifier. So the rectification is here that you can observe. So here you can see the full wave diode or the bridge rectifier. So simply you can see the diode is here. These are the four diodes, and because of this, here you can see. So the simple sine wave is converted into the direct current, the DC waves, and here you can see the full wave rectification can be takes place. So diode is the rectifying circuit, simply prevented the negative swing of voltage from conducting. Okay, but this waste half the available cycle, also very irregular, bumpy for far from a good DC sources. So that is why means simply here you can see we can get. So if we want a pure DC, then it must be straight line, and that we can obtain only from the battery. But here also we can get our purpose can be solved, and we can convert mostly AC to DC. So here you can see the full wave dual supply. So from this we can get the two supplies over here, and simply voltage seen by the loads. So this is again the rectification you can see here. And then how we can smoothing out that bumps, and we can get the regulating that we know that we can do with the help of the RC combinations. Okay, RC combination. So we can have we can say the pi section filter. We can have the L section filter, and with the help of that we can do the filtration. But before that, it is better to use the Zener diode or some ICs, and with the help of that we can have the regulations. So these are some of the outputs you can see which we can get from the diode. So simply this is a Zener regulated. As I have mentioned earlier, if we are using the Zener diode, then it must be designed for getting the reverse bias mode. So in case of this reverse bias, you can see this Zener voltage is here, and here you can see this. So Zener diode breaks down at some reverse voltages, can buy at specific breakdown voltages. As long as some current goes through Zener, it will work. You can see here, and this is what we call the breakdown voltage. And at this voltage, it can be used as a voltage regulator. And the simple sum of the conditions for working this diode is, let's maintain some minimal current IZ through Zener, say a few milliampere. So then this V in minus V out upon R1 is equal to IZ plus V out upon R load. So set the requirement of R1, because presumably all else is no. So then it increases too much, the Zener shuts off. So in that way we can use this particular circuitry as a Zener voltage regulator. And these are some of the ICs. With the help of that also we can get the regulations once we convert AC to DC, because only converting DC is not sufficient for any of the electronic circuitry, and that is why we have to use either Zener diode or the ICs. So that also we have seen in detail earlier. So that is why here I am not focusing much, just I am passing from this so that you can remember what we have done during this particular course. Now let us focus on transistors. So if we talk about transistors, as already I have mentioned, the transistors are used for what? So the amplification. The main function of transistor is to do the amplification. And for amplification, we can use the transistor. And again, along with that amplification, there are certain other functions of the transistors also. And if we are talking about transistors, so we can say that transistors are the versatile devices, and it's a really highly non-linear device. It's not a linear device. And because of its non-linear characteristics, we can get more benefits out of it. So two frequent modes of operation like amplifiers or the buffers that can be used, and again as a switches also we can use, because if we see the output characteristics of the transistor, then it has three different regions. We know about the active region, cutoff region, and the saturation region, and depending upon the requirement we can operate the transistors, and in that way we have learned the transistors. Then like a two main transistors, as already we have discussed about NPN and PNP. And again there are several varieties of the transistors also. BJTs, again BJTs are of two types, NPN and PNP. We can see according to our arrow, like away from the base and towards the base, we can divide it. Then again the FETs, the FET, and again in FET there are N channel and the P channel FET. Then again there is a MOSFETs also, metal oxide semiconductor field effect transistors. And these two, the FETs and MOSFETs, are the unipolar junction transistors. And accordingly we can have the different different discussions also. So we will just hit the essentials of the BJT here. MOSFET also we'll discuss later. So already we have discussed these all issues or the things related to the bipolar junction transistors. Now if we want to use bipolar junction transistor as an amplifier, then you can see how do we proceed. So central idea is simply when in the right regime, the BJT collector emitter current is proportional to the base current. Means whenever we are talking any of the transistor, there is one fundamental equation, IE is equal to IB plus IC. And accordingly we can have the like a simply some parameters alpha, beta, and gamma, and which parameters we called as a current gain, and we can relate that current gain, and on the basis of the values of current gain we can have the different applications of the bipolar junction transistors. Now, if we want to use transistor as a switch, then we have to driving to the saturation. We have to operate the transistor into the saturation mode. And once we operate the transistor into saturation mode, then we can have the better application for the switching. Then again as a buffer, so when we want to use the transistor as a buffer, then the best configuration is like we must have to use the common collector configurations. And if we use the common collector configurations, then if we are talking about the gamma that is the current gain in case of the common collector configuration, and the value of that current gain is 1, and that is why this configuration can be used as a buffer, or we call as a unity gain configurations. So in that way we can use this. And then now let us see the improved Zener regulator, that also we have already discussed. So that can be improved with the help of using the transistors. So already we have the Zener regulator, and again if we are giving output of Zener regulator to the transistors, and then if we take the output with respect to the load, then again we can get the improved Zener regulator, and in that way also transistor has the application for the regulation of the voltage. So that is again one more beautiful application of the like a transistors. Then switching power supplies, you can see the power supplies without transformers, so lightweight or the low cost and can be electromagnetically so electromagnetically also we can see that. Am I audible? Yeah. Okay, so in that way we can have the switching power supplies, that also we have seen the DC to DC conversion process that relies on the flipping a switch on and off, storing energy in an inductor and a capacitor, that can be used here. Then like a switcher topologies, that also we have seen in detail. Now just we are moving, we are passing what we have done. So like a step down calculations we can see here. So some of the calculations are simply step down, and this is what we can see. The impedances, as we know, the total resistance offered by any of the circuit. And if we want a good amplification, then input impedance must be the high. And that is what we can get in case of the FET. And that is why in some application, the FETs are most powerful rather than the BJTs. So that is also needed over there. So these are some of the phasor diagrams that we know already we have discussed. So, so friends, this is what we have just discussed about the PN junction diode and the transistors. So these two are the most important things already we have shared. Now let us focus on the solar cells, photodetectors, and LEDs. So already I have shared where we can use this particular kind of the devices. So solar cells, everybody knows nowadays. Earlier it was using for heating the water, but nowadays it can be used for the generation of the electricity also. So these are again one of the functions of the solar cells. So that is what we know the solar cell. Then simply as we know, the optoelectronics are beginning to emerge in biology and medicine. So that is again typical applications of the optoelectronic devices. So the mostly the solar cells and LEDs are the part of the optoelectronic devices. Along with that, some lasers can be used as a optoelectronic devices, and these all kinds of the light can be generated with the help of using rare earth materials into some of the host matrices, and that gives us the typical emissions, and that emission matters a lot for the generation of either we can convert, or we can get the LEDs, or we can get the simply as we know on the laser that can be formed with the help of that. So again, you can see century 2007 marks a century of the optoelectronics, and you can see that already we have discussed who has invented, in which year invented, and who got the Nobel Prize for the blue LEDs and all. So that already we have discussed, and that is why I am not repeating, just I am passing from these slides. So we can just move from these slides, and these are some of the applications like a flat panel displays, solid state vehicle lighting. Everybody knows now the LEDs are mostly used in any of the vehicles for the headlight as well as the tail light and all. So and means the because LEDs can save the light, and LEDs are the most powerful source of the light also. So here you can see we can now have the, and now in addition to inorganic material, there are some organic compound which also emits the light. So you can see the beautiful light emitted by the organic compounds, and from that some of the devices are also made. So you can see this organic light emitting diodes. So and how the light can be generated, how these particular pairs of the ions will can generate the light. So here you can see the metal contact and some transparent contact. In between that, some polymer is there, and that is deposited on some of the substrate. And once we excite this by using certain source or the by using the electrical energy, then we can get the light generation of the light. So as we know, these are some of the examples of the OLED displays. So you can see some of the examples, very beautiful displays there if we use the OLED. Then already these are some of the applications of the LEDs, photodynamic therapy, we call it the PDP. So that also use or that can be done with the help of that. So you can see the impact of PDT. This is before, this is after. Then potential of OLED for the PDT already we have seen. These are some of the typical devices application cycle. So up for how much time and all like that, and then it can cure. So you can see the beautiful applications of the LEDs. So then now simply if we move ahead from this LEDs to another devices, as we know we called as a lasers. Then again we know instead of the spontaneous emission we require the stimulated emissions, and with the help of that we can generate the laser, and that is why the or the in that way the laser is different from the LEDs. LEDs or any of the lighting. In case of any of the lighting, we can get the spontaneous emission, but in case of the laser, so we are getting the force emission. So where we can just forcefully excited the emitted atom by using again some additional photons, and because of that the energies of the emitted photon will be enhanced, and in that way we can generate the laser we can see here. So there is optical resonator in between that. Now there are two mirrors. One is 100% reflected, another is partial reflected. And again, there is some pumping source. And because of that pumping source, whatever the photons are generated, they are getting just to and fro movement in between that. And because of this to and fro movement, they can generate or amplify the light. So you can see a semiconductor diode laser chip is here. So you can see here absorption of light by measured Ugemuge force. And so this just I'm moving from that. These are some of the applications. You can see the treatment of varicose veins with the help of laser nowadays. It's most important. Here also you can see screen resurfacing using the lasers. Electronics. So here simply the multi-photon excitation is localized both in space and in time. So simply you can see how the light can be generated. So simply here you can see. So there is a ground state. The atom is excited with certain wavelength like 350 nanometer. But again, after when it emits, it gives us the 450 nanometer. You may be knowing we are exciting some phosphors in a UV region, but we can get the emitted light in visible region, or reverse of that also can be happened. We can excite some phosphorus in NIR region and we can emit, or we can get the emitted light in like a visible region, or we can excite into visible and we can get emission into ultraviolet region. So this is also possible, and accordingly we can say it has up conversion and a down conversion mechanism. So here you can see some mechanisms are there. So how two photons can be used for the excitations, and with the help of that we can generate the single photon. Here also you can see 3 photon excitation by 1050. I told you about the NIR region, but at the end you can see here we can get the emitted emission is 450 nanometer. that is in visible region. And in that way we can generate a very much powerful light, so with the help of these particular mechanisms. And accordingly we can say this is as a this is a up conversion. Okay, so this is basically down conversion. So in that way we can have the generation of light through the different materials. So here you can see some of the already we have discussed this all. I'm just passing from this all. Okay, so just as a revision sort of things. Now let us focus on some applications of LEDs or the laser into the optical fibers. So as we know, when we are talking about optical fiber, so the optical fibers are like the simply we know the core, the diameter of the core is you can see only 8 micrometer. And if we want to signal through this, then we must require a narrow source of light. And that is why we are just selecting laser as a source of light. But nowadays some LEDs are also fulfilling the purpose of sending the signal through optical fibers. So then here you can see some core is there surrounded by the cladding. Everybody knows how it works. Okay, so I'm just moving from this optoelectronic communication. Everybody knows nowadays most of the communications are done with the help of the optical fibers. And because of that, we know the instead of now in place of this 3G, we are having 4G. Now 4G is surpassed by the 5G. So in that way, we are having technological advancement. So you can see here some of the yes. I'm just moving from this peace and weapons already we know. And solar photovoltaics already I have shared with you. If you are talking about solar photovoltaics, so I told you the mostly silicon based solar cells are used. So now but these silicon based solar cells are basically everybody is trying to enhance the efficiency of this solar cell. Okay, so here you can see some of the solar cells or the solar panels are there. And everybody knows this is what how the photovoltaics can work in solar panels. And solar panels are simply as we know, the solar panels are having a very important use when we if we talk about this Chandrayaan 3 or like Aditya L1. So then we know without solar panel we cannot imagine imagine the output or the outcome from this kind of the spacecraft or any of the a major like achievements done by the ISRO. So friends, that is why it is most important to learn about the solar panels and the photovoltaics also, how it works. So that also we have seen in detail how it is, which type of the materials are used, which are the best materials. So that we have covered in previous sessions. So just you can see these are some of the silicon photovoltaic solar cells. So and the response of these all you can see here. And these are some of the batteries and its response. The economics that is not most important for us. So we are moving from this. So this is what all about the solar cell. So if we want to conclude about the optoelectronic devices, then we know optoelectronic devices have come of age and have opened up the wide range of exciting possibilities both within the science and in the products used in everyday life. So as we know, from early morning, we are using the screen of the mobile, and if there is no optoelectronic devices, then we can't imagine the mobile, or we can't imagine the mobile phone. So the screen plays a very vital role, and screen is made up of the optoelectronic devices. And there are redefining many of the boundaries of the modern life and technologies, as we know. It's means there is a huge role of the optoelectronic devices, as we know the earlier like a televisions that was the CRT base, now replaced by the then earlier it was replaced by the LCD or the plasma, and now everything is replaced by the LED based televisions and or the OLED, organic LED based televisions. And again, as we know, some knowledge of the optoelectronics is vital for all of us living in the 21st century. It's really essential. Without that, we cannot move, we cannot proceed. So it follows therefore that the teaching of some practical skills in optical should now form an exciting part of the modern science curriculum. Now, the last part of your syllabus is analog to digital converter and digital to analog converters. So, why this is important? So, already I have discussed. So, conversion of audio signals like a mobile micro or the digital music records is really essential, or the conversion of the video signals like a camera or the frame grabber, etc. And that can be measured really, some of the values we can measure like will so temperature, pressure, or the luminance. So as we know earlier, we have some of the things to measure, like we are having the thermometer, and that was mercury based. Now this mercury based thermometer is replaced by the digital thermometer, and digital thermometers gives us the precise and accurate reading as compared to the mercury base. Even the mercury base is also giving the precise and accurate, but it's very much it depends upon the human error. How do we measure it? So that error can be minimized if we use the digital signal instead of the analog, and that is why analog to digital conversion is most important, or the digital to analog is also equally important. And that is why here you can see this is the analog signal that can be converted to digital signal. Here you can see simply, and analog input can be voltage or current in the following only voltages. We follow only voltages, but it may be the current or voltages. So analog input can be positive or negative, so we are just following the positive for the calculations, but it may be positive, it may be negative also. So this is what we can see here. Then some of the characteristics values of the analog to digital converters, like which values characterize an ADC, what kind of errors exist, what is like aliasing. So here you can see ADC value. So resolution. So resolution then that can be denoted as n. So number of discrete values to represent the analog values in bit. So 8 bit is equal to 2 to the power 8 or the 256 quantization level. Then 10 bit is equal to 2 to the power 10 or the 1024 quantization level. Then the reference voltages, that also matters. So analog input signal V in is related to the digital output signal D out through the V reference. So here you can see V in is equal to V reference, and we can have this output. So ADC value the simply VLSB. So minimum measurable voltage difference in ideal case. LSB is least significant bit. So how much we can measure, that is also matters. So one of the example is given. So signal to noise ratio also plays a very vital role when we convert analog to digital or digital to analog signal. Then ENOB, effective number of bits. So and SINAD, signal to noise and distortion ratio. Fundamental signal to sum of all the distortion and noise. Okay, so you can see this ideal ADC. So we must expect this type of the waveform, but always we are not getting this type of the waveform. So here you can see some of the ADC values like a bandwidth, maximum measurable frequency of the input signal. So that is really important. Power dissipation also, conversion time, time for conversion of an analog value into a digital value. Interesting in pipeline and parallel structures. Sampling rate. So rate at which new digital values are sampled from the analog signal. Errors, quantization, offset, gain, INL, DNL. So these are again some of the parameters. So here we can stop for today's class. So we have learned and we have revised all the aspects of simply you may be knowing. Okay, all the aspects of the electronic and experimental methods. So when we talk about this electronic and experimental methods, then we have covered most of the things which is given in syllabus during this course of time. So now let's whatever questions you have. So please feel free to ask the questions. So I'm just waiting for your question and answer. So feel free to ask the questions.